Hey there and welcome to Calculus with Miss Heineman. So here's our first homework assignment, homework number 1. It's a worksheet, so we're looking at some pre-calculus practice. So I think these are some pre-calc skills that you'll see in the first week or two of our class. So if you look at number 1, find the slope between 2 points, -2, 5, and 4, -8. There's two ways I think that you can do this. Just use the slope formula, so the difference between the y-coordinates, 5 minus -8, so that's really 5 plus 8, over -2 minus 4, and just be careful there, make sure you're pulling your x and y coordinates from the same ordered pair first. So our slope here is 13 over -6. If you like to use the t-table here, you can write down -2, 5, and for -8, and actually just look at the differences here. So in the x-coordinates, to go from -2 to 4, that's a jump of +6, and then to go from 5 to -8, we're going down by 13, so that'll still give us the same slope here, 13 over -6. 2 and 3 deal with writing equations of lines. So if I look here, our equation has a slope of -3 with a y-intercept of 0, -13. And then for number 3, we have a slope of -3, but an x-intercept of -13, 0. I like using the point slope formula. You might like using slope-intercept, which is fine as well, but I think with point slope, once you write the equation, you're done. You don't really have to do anything else. So it's y minus the y-coordinate you're given of the ordered pair equals the slope times x minus the x-coordinate that you were given. So for number 2, that's the same as y minus -13, or y plus 13, equals -3 times x minus 0. Or if you like slope-intercept, you can write it as y equals -3x minus 13, since they gave you the y-intercept, and that's really nice. For number 3, we got y minus 0 equals -3 times x minus -13. That becomes a positive 13, and you can leave it just like that. For number 4, we're looking at a 2-part question, so I probably need some more paper here, so let's scroll down a little bit. I want to find the distance between the points -6, 4, and the intersection of the system here, 8x minus 9y equals 19, and 4x plus y equals -7. I'm just going to do all of this without the calculator, just because you just need practice with non-calculator work. And if you want to use your graphing calculator, that's fine, that's up to you. So I've got 8x minus 9y equals 19, and my second equation here, 4x plus y equals -7. And what's nice about this one is with this second equation here, I can rewrite it so that I've got y equals -7 minus 4x, and then I can do substitution here. So I'll do this substitution, and so now I've got 8x minus 9 times -7 minus 4x equals 19. So we've got 8x plus 63 plus 36x equals 19, which gives me 44x equals -44. So x equals -1. If we substitute our x value back in, y has to equal -7 minus 4 times -1, which is the same as -3. So my ordered pair from here is -1, -3, and now I want the distance between these points. So if you want to, you can use the distance formula, which is totally fine, and I'm just going to write it out here. If you can't remember it, d equals the square root of the distance between the x-coordinates squared plus the distance, or the difference between the y-coordinates squared as well. Just done that. I like to use it the same formula but geometrically, and so really what I'm using is Pythagorean theorem. So I'm just going to make a sketch. Right, so we have negative 6, 4 here, and I've got negative 1, negative 3 here, and so I'm looking for that distance. And so I can look at the vertical and horizontal change, and that's the same as looking at the legs of a right triangle. So my vertical change here is 7, my horizontal change here is 5. So I'm really looking at 5 squared plus 7 squared equals distance squared. So 25 plus 49 equals distance squared. 74 is my distance squared, so my distance must be the positive square root of 74. And if you get a decimal answer for that, that's cool too. So for our last problem here, we're looking at a composition of functions, and that becomes really important in the class later on. A little bit now, but later on a whole lot. So I'm just going to rewrite these functions. F of x is equal to x squared. G of x is equal to 2x minus 1, and h of x equals 2 to the x. So for 5a, we're looking at f of g of 2. And so I'm actually going to find the value of g of 2 first. Remember, with composition of functions, we work with the innermost function back out. Do some scratch work here. So g of 2 is the same as 2 times 2 minus 1, which is 4 minus 1, so g of 2 is 3. And just go back there and replace this. So f of g of 2 is the same as f of 3, and f of 3 is the same as 3 squared, so we're looking at f of g of 2 equaling 9. Okay, so now if I look at 5b, I'm looking at g of f of 2. And so, similarly, I'm going to look at f of 2 first. And I've got f of 2, which equals 2 squared. So f of 2 is 4, so I'll go back and plug that in. So g of 4 is equal to 2 times 4 minus 1. So that's 8 minus 1, so that's 7. So g of f of 2 is equal to 7. So for C, I'm looking at f of h of negative 1. And so we're going to look at h of negative 1 first. And we're going to look at some of our exponent properties. So 2 to the negative 1, if I want a positive exponent, I just take the reciprocal of this. So I've got 1/2. So I'm really looking at f of 1/2. And f of 1/2 is the same as saying 1/2 squared. So f of h of negative 1 is the same as 1/4. For 5d, we're looking at h of f of negative 1. So we'll look at f of negative 1 first. So we're looking at negative 1 squared, which is positive 1. So I'm really looking at h of positive 1, which is the same as 2 to the first, which is just 2. So h of f of negative 1 is 2. For E, this one's kind of a fun one, but maybe that's just because I'm a math teacher. I don't know. You might think it's fun too. But E is asking us for g of f of h of 1/2. Okay, so innermost function first. So we're looking at h of 1/2. Scratch work here. H of 1/2 is the same as saying 2 to the 1/2. And that's equivalent to saying the square root of 2. And we can just leave it as root 2. So now I'm looking at g of f of root 2. And f of root 2 is what we're going to look at next for evaluating. And f of root 2 same as saying root 2 squared, and the square root and the squaring undo each other, so we have 2. So I'm really looking at g of 2, which is really nice. And that's the same as saying 2 times 2 minus 1, so 4 minus 1. So g of f of h of a half is equal to, let's see here, do I need another parenthesis? Yeah, 3. Okay, so now for the last few here, instead of plugging in a value, we're coming up with functions. So first we've got f of g of x. Now if you remember what g of x was, if you look here, g of x is the function 2x minus 1. And so this is equivalent to f of 2x minus 1. And if you remember what f says, it's the same as saying whatever your input is squared. So this is 2x minus 1 squared. We can leave it like that or multiply it out. I'll just multiply it out because it's just good for us. So this is the same as saying 4x squared minus 4x plus 1. And I can rewrite it that way. 5g, we have g of f of x. So we'll look at f of x, which we know is x squared. And so really we're looking at g of x squared. And if you remember what the function g is, it's 2 times whatever our input is, minus 1. So it's 2 times x squared minus 1. So g of f of x is the same as saying 2x squared minus 1. So we're now going to look at this one, g of x. And just break it down again. G of x we know is 2x minus 1. So now I have g of 2x minus 1, and 2x minus 1 is my input. And remember, g is 2 times whatever my input is, minus 1. So I'm going to plug in 2x minus 1 and just simplify that. So I distribute the 2, so I get 4x minus 2 minus 1. So g of x is 4x minus 3. And finally, we have f of h of x, and h of x is 2 to the x. So I really have f of 2 to the x. If you remember, what f does is that it takes its input and squares it. So we have 2 to the x squared. And because of our exponent rules, this is equivalent to 2 to the 2x. And there you have it. First homework assignment done. Good job.